Bangladesh's consideration of the JF-17 Block III fighter jet marks a pivotal moment in the country's defense modernization program, and it is rooted in both practical needs and long-term strategic planning. This development does not exist in isolation. It is shaped by years of gradual capability building, assessments of regional air power balances, and the limitations of its existing fighter fleet. The Bangladesh Air Force (BAF) currently operates a fleet of aging combat aircraft, many of which were acquired decades ago and are increasingly difficult and expensive to maintain. These include airframes with outdated avionics, radar systems, and propulsion technologies that limit their operational effectiveness in modern combat scenarios. The BAF has long recognized that a technological refresh is necessary to remain credible in the face of evolving regional threats, growing airspace complexity, and increased reliance on air power in multi-domain operations. The JF-17 Block III has emerged as a practical and focused solution to meet these challenges. At the core of Bangladesh's interest in the JF-17 Block III is its cost-to-capability ratio. Most high-performance fighter jets available on the international market are prohibitively expensive, not just in terms of unit cost, but also in terms of maintenance infrastructure, fuel consumption, and logistics support. By contrast, the JF-17 Block III has been designed with affordability and maintainability as core principles, offering an efficient path to acquiring fourth-generation plus capabilities without incurring long-term economic strain. This fits well with Bangladesh's procurement philosophy, which prioritizes sustainability and independence over prestige or complex acquisition cycles. The technical enhancements in the Block III variant address virtually every operational limitation observed in earlier versions. The most notable advancement is the incorporation of the KLJ-7A active electronically scanned array AESA radar. AESA radar systems are now considered essential for modern combat aircraft because they provide vastly improved detection ranges, target tracking, and electronic countermeasures. The radar's ability to simultaneously track multiple air and surface targets makes it highly effective for both air superiority and precision ground attack roles. Furthermore, its low probability of intercept makes it more difficult for adversaries to detect, improving both mission success and survivability. In addition to radar, the Block III features an integrated electronic warfare suite that includes radar warning receivers, missile approach warning systems, and self-defense jammers. These systems collectively enhance the aircraft's ability to survive in hostile airspace where threats include radar-guided and infrared-guided missiles. Bangladesh's Air Force would greatly benefit from this self-protection suite, particularly during patrols, intercepts, or maritime surveillance missions in contested areas. The aircraft's digital fly-by-wire flight control system marks another substantial leap. Unlike mechanical or analog systems, digital fly-by-wire systems allow for more precise and stable flight control, reduce pilot workload, and improve maneuverability. They also offer redundancy and safety advantages, reducing the likelihood of loss of control incidents in combat or poor weather conditions. For the BAF, which operates in a diverse geographic environment, including coastal, jungle, and urban terrain, this kind of control precision is critical. The cockpit is built around pilot-centered ergonomics, featuring a wide-angle head-up display (HUD), large multifunctional color displays, and a helmet-mounted display and sight (HMDS) system. These systems enhance situational awareness, enabling the pilot to simultaneously monitor the battle space, target data, and aircraft systems with minimal distraction. The HMDS system, in particular, allows for high off-boresight targeting, meaning the pilot can look at a target and cue weapon systems in that direction without needing to maneuver the aircraft nose directly toward the enemy. This capability gives the pilot a critical edge in close-range engagements and asymmetric air combat. The JF-17 Block III is powered by the RD-93MA turbofan engine, which is an upgraded version of the RD-93 engine used in earlier models. The new variant provides higher thrust, better fuel efficiency, and improved reliability. These upgrades translate directly into operational benefits: a higher thrust-to-weight ratio, improved acceleration, and longer mission endurance. For Bangladesh, this means greater flexibility in deploying the aircraft across its airspace without worrying about limited reach or combat persistence. From a mission profile perspective, the aircraft is capable of multi-role operations. It can perform air interdiction, close air support, tactical reconnaissance, maritime strike, and defensive counter-air missions. Bangladesh's defense posture requires exactly this type of platform, one that can be deployed rapidly, adapted for different roles, and sustained without significant foreign assistance. Furthermore, The aircraft's ground attack capability includes targeting systems that enable day-night operations with precision guidance, essential for modern military operations in urban or complex terrain. The potential deal under consideration reportedly involves the acquisition of up to 24 to 32 aircraft, with options for follow-on units depending on operational performance and budget alignment. This number would allow the BAF to form at least 2 full-strength squadrons, ensuring sufficient numbers for both operational deployments and training requirements. Such a deployment would likely be structured in phases, beginning with a lead-in training and conversion program, infrastructure development including hangars, simulators, and maintenance facilities, and then full squadron formation. Bangladesh is also evaluating the long-term support ecosystem that comes with the aircraft. The JF-17 Block 3 includes built-in diagnostic systems and modular components that simplify field maintenance and reduce downtime. This means that with proper training and logistics planning, Bangladesh would be able to maintain operational readiness without relying heavily on external support, a critical factor for national air sovereignty. Another key factor is the potential for industrial cooperation. Bangladesh has a modest but growing defense industrial base, and any agreement could include provisions for technology transfer, local assembly, or component manufacturing. This would not only reduce reliance on foreign parts but also stimulate domestic skill development in aviation technology and maintenance engineering. From a defense policy standpoint, adopting the JF-17 Block 3 would align Bangladesh with a platform that is gaining traction among other regional users. While the aircraft is not operated by all regional air forces, its growing international footprint may open up shared training opportunities, spare parts economies of scale, and broader operational experience sharing, which would benefit Bangladesh over the long term. In terms of risk mitigation, Bangladesh is conducting thorough evaluations involving its Air Force pilots, engineers, and defense planners. This process includes flight simulations, scenario-based assessments, cost modeling, and infrastructure audits. The goal is to ensure that any new platform introduced into the Air Force is not just tactically effective, but also operationally sustainable and strategically coherent with Bangladesh's defense doctrine. Bangladesh's possible acquisition of the JF-17 Block 3 is a reflection of deliberate planning, technological ambition, and operational realism. It is a fact-based pursuit of a fighter jet that offers high performance, modern systems, and logistical sustainability within a manageable budget. If the deal progresses to completion, it will represent a major leap forward in Bangladesh's air power capabilities and will shape the force structure and defense posture of the country for many years to come.